we're going to do all of 5.3. So I got the 5.3 up here. Then we'll talk about the test after I'm done with that. So we just have a little bit more to do on 5.2. So I want to go ahead and start with that. So let's see. Of course, we didn't have class last Wednesday because of the snowstorm. And this one, we're just going to look at a system of inequalities. And we're going to run through linear programming and stuff today. We're just going to see if these are solutions. And then what you have to do is you have to check this in every inequality. So if you're going to see if 1, 1 is a solution, you want to plug into the first inequality. The first inequality is 2x plus 3y less than or equal to 18. So you'd have 2 times 1 plus 3 times 1 less than or equal to 18. Now, if you can do that in your head, that's good. I mean, that's a yes. That definitely is right because 2 plus 3 is less than 18. Okay. If I plug into the second one, the second inequality is 1 minus 1 greater than 2. So I would have 1 minus 1 greater than 2. Well, that's 0 greater than 2, so that's a no. Okay, so the answer to that first one is that's not a solution. What I'm doing is everywhere I see an x, I plug in a 1. Everywhere I see a y, I plug in a 1, and I just see if they work or not. This is 5.2, page 3. Okay, all right. So the next one, same thing. We have x equals 2, and we have y equals 1. You want to just plug into each inequality and see if it works. So the first inequality would be 2 times 2 plus 3 times 1 less than or equal to 18. Is that right? That looks like 4 plus 3 is 7. I mean, you can write out the step if you need to. That's just saying that 7 is less than equal to 18, so that's good. Now you have to move to the next equation, so you would say 2 minus 1 is greater than 2. Well, that would end up being 1 greater than 2, so that's no. Okay, so the same thing happened on that. It didn't work in one of the equations, so that's not a solution. It has to work in all 4 of those at the same time. And then this last one, x is 5, y is 2. Simply plug in, start at the top one. The top one would be 2 times 5 plus 3 times 2. We'll see if that's less than or equal to 18. If you did that, that would be 10 plus 6. That would be 16 less than or equal to 18, so that works. Okay, plug it in the second one, which would be 5 minus 2 greater than 2. So that would be 3 greater than 2. So that also works. Okay, so everybody see what I'm doing? Okay, I'm just simply plugging in and seeing if it works or not. If you go to the next one, the next equation is x greater than or equal to 0. Well, x is 5. So 5 is greater than or equal to 0 is also right. Okay. The last inequality is y is greater than or equal to 0. Well, y is 2 in this problem. So 2 is greater than or equal to 0 would also work. So the only one that works is this one. The first 2 did not work. So what I'm wanting you to know on this is the way to tell if a point is a solution to a system of inequalities is it basically has to check in everything at the same time. If it doesn't check in one, then it's no good. Okay, does that make sense? Okay, you just need to know x is 5, y is 2, plug in and verify. That's what you're doing, okay? All right, now what we're going to get into now in this, this example, we're going to learn how to do these graphs of this type of system of inequalities. So we start this kind of like this. Now we're going to do this in a little bit different way with intercepts, okay? So let's start by writing down the first inequality, 2x plus y less than or equal to 10. Now you could solve for y if you want to. I'm going to try on the rest of these examples to just have you do intercepts in your head as much as you can. So we're going to find the x-intercept and we're going to find the y-intercept, and I'll try to get to where you can do this in your head because it's not that hard. When you do an x-intercept, you just replace the y with 0, so you would get 2x plus 0 less than or equal to 10. Okay, that would be 2x, and you can just use an equal sign. 2x equals 10, you can solve that in your head, that's 5. Okay, so what you would do is we're going to have an x-intercept of 5, when we do this graph. When you do a y-intercept, you're going to let the x go to 0. So you have 2 times 0 plus y equals 10. That will be y equals 10. Okay, now what I'm going to do is show you how to do this in your head. I mean, you don't want to forget why this works, but if you want to find an x-intercept, all you do is do that. Block that off. What's the answer to the equation 2x equals 10? 5. It's 5, see? If you want to find an x-intercept or a y-intercept, block that off. What's the answer to the equation y equals 10? It's 10. So you want to be able to see that the x-intercept's 5, the y-intercept is 10. Okay? So what we're going to do before we do anything with the other inequalities is we want to go ahead and just get this set up. So let's just go out and kind of go by 5. Let's label the x-axis 5, 6, 7, 8, 9, 10, like that. And let's do the same thing on the y-axis. Let's just go 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10, like that. Okay, now I'm going to do this first graph. I'm just going to pick a color. I'll do that like in red. Okay, so here's what you want to do. Since the x-intercept is 5, put a dot on 5. Since the y-intercept is 10, put a dot on 10. All right. Now what we're going to do is connect those dots. Now you have to remember these things we talked about last week. If that's less than or equal to, is it solid or dashed?
Dashed.
Solid, okay. If that wasn't there, then it would be dashed, okay. So you want to take that into a solid line like that. So just go ahead and connect that into a solid line like that, okay. The other thing that you want to know is this is a less than. Since it's less than, you're going to shade below. Okay, now we're not going to shade below until the very end on this problem, but maybe make like an indicator. This is what I was showing you guys last time. So just make sure that you understand that right now you're below that. Okay, just some way to keep track of this is what you got to do. Okay, all right. Now what I'm going to do is I'm going to take the second inequality and we're going to graph it. I'm going to write this over here. So that second inequality is x plus 2y less than or equal to 8. Now I want to get you guys to where you can do as many of these intercepts in your head as possible. All right, tell me what the x-intercept is. 8. Okay. Tell me what the y-intercept is. 4. Does everybody see what I'm doing? X-intercept, block off y. Y-intercept, block off x. You can do that in your head if you want to. Okay, so we would have x is 8, and then you would really have 2y equals 8, so we'd have y equals 4. Okay, so I'm going to do this second one like in green. So what you want to do is put a dot on the x-intercept of 8, put a dot on the y-intercept of 4, and then connect the dots. Again, it's going to be a solid line, and it's also going to be shaded below. Okay, so what you want to do is go ahead and connect that. Then you want to just kind of make a note to yourself that you are below that green line also. Just get that in your mind, okay? All right. Now, here's what this means. These two conditions here just mean that x is positive. So that would mean that, that's the reason why I'm not doing a graph over here, by the way, because we're looking over here. This condition says y is positive. So we're up here, all right? So what you want to do on this now is, these are your possibilities. There's 4 possibilities of where you shade this. Let me just number what they are. One possibility would be that, this little thing there, and then 4. Okay, so what you get is you get these figures right here. So you can either be in this triangular region, this region here, that little triangle, or this huge area out there. What do you think? You're right there because you're below both. If you're below both lines, then you're in here. Okay, so what you're going to do is you're going to take your pencil or whatever and shade just this part right here. Okay, so that gives you what you call the feasible region like that. Okay, so you have to determine which of those 4 places you're in. That's because you're below both lines at the same time because they're both less than symbols. Okay. Now, what this means is we're bounded. What I mean by bounded is Bounded would be that you can draw a circle around that. Okay, this has boundaries. If you shaded up here, it would go on forever. That would be unbounded. If you shaded in that triangle, it's bounded. The only time unbounded is going to be if the shaded region goes on forever in some direction. So that's bounded. Okay? The next thing we're going to do is we're going to find what we call corner points. And I'm just going to have you draw a kind of a little picture over at the side. The shaded region that we do, that we just shaded, looks something like that. It's a four-sided figure, and these things that's got 4 corner points. So we're going to name all of those corner points. Some of them we'll be able to do in our head. One of them we'll have to probably do a matrix on to find the intersection point. Okay, so this point right here is 0, 0. Okay, that's what that point is. This point is 5, 0. Okay, and then this point right here is 0, 4. Okay, those you just look at the graph and you can determine that in your head. This one right here we don't know. You're not going to go by looks. We're going to do a matrix on that then. So far the corner points, it doesn't matter what order you put them in, would be 0, 0, 0, 4, 5, 0, and then we got to find that one other corner point like that. Now what we're going to do is we're going to do a matrix on this. So what you do to find this corner point, since it's the intersection of 2 lines, we're going to do the matrix 2, 1, 10. And so I'm just writing this in an augmented matrix. Then we'll just do that on the calculator. Now a lot of these things I've kind of worked out before class to save a little bit of time on some of this. But let's put this one in the calculator then, okay? And let's find what that is then. So let me pull my calculator up. So what I'll do is I'll put in that matrix, and we'll put it in a reduced row echelon form. That'll give you that intersection point. So again, I go to the matrix. I'm going to do edit. I'm going to put this in matrix A. I've got looks like a 2 by 3 matrix. So I got 2 by 3 matrix in. Just put the numbers in. 2, 1, 10. So I got 2, 1, 10. Then I've got 1, 2, 8. And to me, this is the fastest way to do this, is just do this on a matrix. Okay, I'm going to get to a clear screen. Then I'll do reduced row echelon form. So I go second matrix, math, and then go down to the one that says RREF. Do that. Get matrix A to come up. And this is what we've been spending the last couple of weeks on. And that will give you this. So this matrix becomes 1, 0, 4, 0, 1, 2. So what's the result of that matrix? 4, 2. Okay, so that means that corner point is 4, 2. That 4, 2 is the solution, so that gives you the other corner point of 4, 2. So typically what you're going to do in this type of situation is some of the corner points you can do in your head. You're just going to tell by what you graphed what they are, but you may have to do the intersection with a matrix if that comes up. Okay, now we're building up to a linear programming problem today is what we're doing. And that's primarily the 90% of what you do on linear programming is graph an area, find corner points, and then we're going to learn to do something with those corner points in a little bit. Okay? Is there any question about what I did? Okay, you're going to get to a point where on these things that you can graph it real quickly. Just get your X and Y intercept. If they're both less than, it means they're going to be below. So you're going to be below both lines. That can be different regions depending on what your inequalities are. Okay, and then use that matrix to find that one corner point. Okay, we'll do several of these to kind of get the idea, and I'll let you maybe try one of these here in a minute and see if you can put this together. Okay, what we're going to do with this one is we're going to graph. We're going to start by graphing this. And again, what I want you to be able to do on this is kind of quickly be able to figure out these intercepts in your head, okay? Can you tell me what the X-intercept is? 4, right? What's the Y-intercept? 8, okay? You want to do it that way because it's fast, okay? So let's just write that down. X equals 4. y equals 8. Okay, now we're going to probably need to go down and scale this. We can do this about the same way. We can just go, let's just go up like this. 1, 2, 3, 4, 5, 6, 7, 8. That's probably as far out as we're going to have to go. And same with y. 1, 2, 3, 4, 5, 6, 7, and then 8 like that. Okay, so what you want to do is just put in your intercepts. You have an x-intercept of 4. You have a y-intercept of 8. Okay, you're going to use a solid line. Okay, so you just connect the dots like that. All right. Okay, now, where's the shading going to be? That's greater than. So is it going to be below or is it going to be above? Above. It's going to be above. Don't shade yet. Just understand that you're going to be above that. So again, what I've been kind of showing you to do is just kind of make a note to yourself that you know that you're above. Okay, that'll take care of that. Okay, so now what we're going to do is we're just going to do the second one. Okay, so I'm going to write that down. I got x plus 2y greater than or equal to 4. Okay, can you tell me what the x-intercept is?
4.
4. What's the y-intercept?
2.
2. Okay, just do that in your head. 4 and 2. Does everybody have that? Okay, that's important. That you can do that quickly and efficiently in your head. So you're going to get x equals 4 and y equals 2. Okay, so what I'm going to do on this is just put a dot on 4, which is the same place. That's right there. We already had that. Then you got one on y equals 2. And then again, you have a greater than, so it's going to be solid. And it's also going to be above because it's greater than. Okay, so that's what we got so far is we have that. Okay, now I'm going to put a little indicator to myself that I'm above that. So basically in your mind, you got to think, I'm above the red line and I'm above the green one. So you got to think about where it would be on this. And you really on this problem, you have three choices. You got this area, which is a triangle. That triangle in this area way, way out there. Which one do you think it is?
The big one.
It's the big one, right? Because you have to be above and above both. So it's going to be this area out here. So what you're going to shade is the big region like this. Okay, it's above both lines at the same time. So that's where it has to be. Okay, and just kind of shade that in with your pencil like that. Okay. Is that bounded or unbounded? Unbounded means it goes on forever. So that's unbounded, right? So that's unbounded, okay? Now your corner points go like this, okay? Basically the region that you have is your corner points are going to be these things. This dot, and that's it, okay? Because the region that you graphed looks like this, basically, okay? The region is unbounded, so it goes like that. So these corner points we know. This point right here is 0, 8. So that's a corner point. And then this point right here is 4, 0. You don't have to do a matrix on that because you know the corner points. Okay? So you could have, if you have greater than and greater than, then that's going to put you up in the big region that's above everything. Okay, does that make sense? Okay, just make sure you're trying to figure out once you get your lines drawn where the region is, okay? All right, now the next one you got to be really careful on this next one if you do it this way. All right, so let's take a look at this. We're going to do the same thing. Now there's a couple of things you need to be super careful about on this, so pay attention. We're going to go ahead and get the intercepts on this first of all. So what is the x-intercept by looking?
4.
4. Be careful. What's the y-intercept? It's negative 8, okay? So if you have trouble doing any of this in your head, then write down the steps. Don't forget really what you're doing. When you do an x-intercept, technically what you're doing is 2x minus y equals 8. You solve that equation. That one's easy to do in your head. You have an x-intercept of 4. Okay, the y-intercept, what you're doing is you're doing 2 times 0 minus y equals 8. Well, you'd end up with negative y equals 8, so then you would have to divide both sides by negative 1, so you get y equals negative 8. Okay, so be careful about that. Don't always just rely on doing it in your head unless you're really competent with that. So what we'll do is we'll go ahead and get this graph. So we just probably need to go, this one we actually need to extend this down a little bit. So I think what I'm going to do on this one, since that y-intercept's at -8, I'm going to have you maybe do this. I think this would probably work okay if we did this. Let's just kind of put us an axis in here. Pick something up there, and let's just pretend like that x-axis is not there. Okay, that way it'll fit. Okay, now let's just kind of do this like this. Then your x-axis, let's just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, just however you want to scale that. And then go 1, 2, 3, 4, 5 like that. And then you can go down 1, 2, 3, 4, 5, -5 like that. And that's a good setup like that. So what we'd have is we have an x-intercept of 4. I'm just kind of redrawing the axis. And then I have a y-intercept of -8. So just go like that. Now this time, here's where you got to be super careful on this and pay attention to this. Okay, so am I going to use a solid or a dash this time? Dashed. Now, here's what you got to be super careful about. You might think below. No, it's not below. The reason is because there's a negative in front of y, and if you solve for y, it would switch the inequality. That's what you got to be aware of in this particular problem.
If it's like a negative y at all, it'll always be.
It'll always flip. Okay, so you can kind of take that as a shortcut. The same thing's going to happen on the second equation too. So what that's really going to do is it's going to become greater than when you solve for y. So what you'll do on this is you'll just do a dash and just take the line as far as you can take it like that. And then it's no longer going to be less than, it's going to be greater than. So you would actually be above that line. Okay, now if you don't quite understand what I was doing, I just didn't show the step. If you solved this for y, you would get -y less than -2x plus 8. Then if you divided by -1, that would cause the sign to switch. So it would end up giving you that. Okay, you don't have to write that down unless you feel like you need to. So if you have a -y in the original problem, you're going to use the opposite sign. Okay, so we've graphed that, and we know we're above. That's what we've done so far. Okay, all right, now we want to go to this next one. So the next one is x minus 2y greater than or equal to 4. So just do the intercepts in your head. So tell me what the x-intercept is. 4. How about the y-intercept? Be careful. -2. Okay. All right. So what we would have is we'd have x equals 4, and then we would have y equals -2. So those are our intercepts that we'll have on this. So we're just going to go to 4 again, which is here. And then we'll go to -2, which is down here. And then this one is going to be two things. The sign is going to change to less than, and it's going to be solid. Okay, why is it going to change? Because there's a -y. Okay, so what you're going to have then is when you connect the x-intercept of 4 to the y-intercept of -2 with a solid line, it's going to go like that. Okay, and again, the sign changed to less than, so it's going to be below. Okay, so you want to kind of think about, okay, I'm below the green line, but at the same time, I'm above the red. Okay, try to think of this where you would be then. You're below the green. So that means you're either there or you're there, right? Well, you're also above the red, so where are you? Here or there? You're there, okay, in that little triangular region right there. Okay, so you're going to shade that triangular region, and then that's what we're going to look at then. Okay, you got to have some method to kind of keep track in your head of what the shaded region is. That's what I do. Okay, some students do this. You can bring in like a different colored highlighters, and wherever they overlap will be where you are. Okay, that's kind of the idea. All right, so your corner points on this would kind of look like this. You're really looking at this region right here. So you've got all of these corner points you already know, so you don't need to do a matrix. This corner point here is 0, -2. This corner point here is 4, 0. And this corner point here was 0, -8. Okay, so you can just tell by looking what those corner points are. So that's 0, -2, 4, 0, and 0, -8. Okay, and this is bounded because it's a triangle. It doesn't go on forever. It's bounded within the boundaries of a triangle. So it goes like that. So the thing that makes this problem a little trickier for students is the reason these inequalities change is y. You have a negative y. Okay, that's what caused things to change. That's why it went above and below because of that change. Yes?
Wouldn't, since it says y is greater than or equal to 0, doesn't that mean that there can't be negative? I don't really get that.
Oh, we are, okay. In this particular, I thought I had written something and left one of those off. Yeah, what would happen on this one technically is if x is greater than 0, you'd have to be here, and if y was greater than 0, you would have to be up there. I meant to leave those things off of this problem, but if they were there, there would be no solution. Okay, so you guys need to scribble that off. I forgot to take that off. So this part here was intended to be off of that problem. Otherwise, it'd be no solution. Okay, all right. Okay, so let's see. That one's kind of a weird situation. The most common situation you're going to encounter is the first two I did. You won't encounter this one very often. Okay, so I'm going to have you try this one. This is the real common situation. Try to put this together. Probably when you start, just, we can probably go by 5 on each axis. And try to do as much of this one as you can. Do the intercepts in your head. Get your graphs put together. Shade the region and find the corner points. And on this particular problem, when you do the corner points, you're probably going to have to use a matrix to find one of those intersection points. Okay, you may have to do that on this problem. You don't always have to do that. It just depends on the situation. So let's see if we got the intercepts. Okay, on the first equation, what's the x-intercept? 10. What's the y-intercept? Okay, has everybody got that and able to do that in their head? Okay, all right, so we'll just put on that 10. We'll put 5. It's going to be solid. Okay, where's the shading go if it's less than? Below. Okay, so far, you know that you would be below. Okay, all right, how about the second equation? What's the x-intercept? 4. What's the y-intercept? 3. Okay, has everybody got that okay? Okay, let me know if you don't, because you want to do that in your head so you can do the problem fast. Okay, so we have x equals 4, 1, 2, 3, 4, like that. Then we have y equals 3 like that. Okay, this is a little bit different than I thought it was going to be. It's okay, though. That would also be solid. Would it be above or below?
Below.
It'd be below. Okay, so we're below both of those lines. There is no intersection, so you don't have to do a matrix. I thought you were going to have to do that. So where are you? If you're below that and below that, where are you? You're there. You're in that little triangle. That's what you should have come up with. So you have to be below both lines at the same time. So that's your feasible region right there. Okay, is that bounded or unbounded? It's bounded. Okay, it's inside of a triangle, so it's bounded. What are the corner points? You can do this one in your head.
0, 0.
0, 0. What else?
0, -3.
4, 0, right? And 0, 3. Okay, so you got 0, 0, 4, 0, and you got 0, 3. Okay, that's the situation you have.
Last time you started with the y, does it not matter which point goes first on the corner points?
Doesn't matter what order. Okay, that's up to you. It's just you got a triangle, so just name the vertices or the corners of the triangle. That's up to you what order. Okay? Is that okay? Okay. The hardest part sometimes for students is figuring out the shaded region. You know, you just got to try to figure out which region they come together. That's less than below both lines. That's why you would get the solution you did. Okay, so we're going to put this together. This is kind of what we're leading up to, and then we'll start a little bit into linear programming. The thing about linear programming, I've taught you almost everything you need to know already, but what we want to do is put together some sort of a situation and model it with a set of inequalities in. So what's happening on this problem, if you read this is a typical kind of thing that we're going to do with linear programming, although we're not going to finish the linear programming problem until the next section here. So this one says that you got two types of water skis. You have a trick ski and a slalom ski. And then it's going to tell you pieces of information. It says the trick ski requires 6 labor hours for doing the fabricating and 1 labor hour for finishing. So when you make that trick ski, that's the labor that's required in doing that. Okay, and then it says this, the slalom ski requires 4 labor hours for fabricating and 1 labor hour for finishing. Okay, so that's giving you kind of your variables on this that we're going to work on. And then if you read further in the problem, it says the maximum labor hours available are for fabricating you have 108 and for finishing you have 24. So we've got, that's kind of the key numerical information in the problem. And then it's telling you that X is the number of trick skis, and it's telling you Y is the number of slalom skis produced per day. So what we're going to do on this one, and all we're going to do, is write our system of inequalities on this, and then we're going to do a graph and then find the corner points. Okay, so we won't finish up every issue in the linear programming problem. Okay, so the first thing that we're going to do with this then is the variables are this. So X, like it says, X is the number of the trick skis. We'll just use what the variables the problem told us to use. And then Y is going to be the number of the slalom skis, like that. Okay, so that's what the meaning of that is then. So we can kind of organize this in a table if we want to, and that will help us to do our inequalities like this. So there's really 2 things that are going on this. And it doesn't matter which way you do the table. We could do, let's just do a row for trick skis, and let's do a row for slalom. And we're going to kind of put this information together like this. Okay, well what it's saying on this is it's saying when you make these things, there's 2 things. You have the fabricating hours. It takes a certain amount to put together the materials, and then it takes a certain amount for finishing. Okay, now you could do this table backwards. You could do the fabricating and finishing and the trick and slalom. That's kind of your choice on that. So what we're going to do is we're just going to organize the information in here. So what it says, if you read the problem, it says if you have a trick ski, it requires 6 hours to fabricate, and it says it requires 1 hour to finish. Okay, so that kind of gives you the 6 hours and the 1 hours. That's what that means. If you read the information on the other one, the slalom ski, it says it's 4 labor hours for fabricating. And then it says it's also 1 hour for finishing. Okay, so that's what that is. Okay, you're just trying to make sure you understand how those variables connect with each other. So when you write your system, it's going to go like this. Right? So basically on the trick ski, what you're going to end up having on this is that's going to be represented by X for those typical numbers. And then the other thing it says is the maximum hours available for fabricating are going to be 108. So I'm going to put the 108 there, and then it says 20, hold on, let's see, finishing is 24. Okay, so you can put that in a table to help you organize your information. Now what you want to remember is the trick ski is X, the slalom ski is Y. So when you put together your inequality, it will go like this. You can kind of read your equation down like this. So your first equation would say 6x, because it takes 6 hours to fabricate the trick ski. Then it's 4 hours to fabricate the slalom ski, but you're constrained by 108 hours. So that's going to be less than or equal to 108. That means that the labor hours can't go beyond 108. So that would end up being an inequality. Okay, the next one would go the same way. It would be for finishing, it takes an hour to finish a trick ski. It takes an hour to finish the slalom ski. The amount of labor available is 24. Okay, so that's how you put that together. So you've got an equation really that this one is for the fabricating, and then this one is for the finishing. So it goes like that. Okay. Now the other thing is X has to be greater than 0. That's because it's the number of skis. That's the number of trick skis. And then Y also has to be greater than 0 because that's the number of slalom skis like that. Hardest part of this problem is figuring that out and putting that together. Now you could have made this chart backwards. You could have made a row for fabricating and a row for finishing. That's your call, but you have to, in your mind, understand that what you're doing is you have that many labor hours for fabricating, that many for finishing, and you're always going to have 2 equations with 2 unknowns in it like that. So now what we're going to do is we're going to complete the graphing and the corner point on this, and then when we do the linear programming in the next section, we have one more step. Okay? So what we're going to do is we're going to go down and we're going to do the graphing on this. So I'm going to just write a couple of notes to myself here. So we're going to start by graphing this, and then we're also going to graph this equation, which is x plus y less than or equal to 24. What you want to do is you want to find the intercepts. Now the intercepts are easy to do on the second equation, but you're probably going to need to use your calculator on the second one. Okay? So let's look at this one first because this is easy. What's the x-intercept on that? 24. What's the x-intercept on that? Y is 24. 24 and 24. So we got that. Okay? All right? So you're going to probably need to use your calculator on the other one. Okay? So we got that. Now what you want to do on the next one is you're really doing this. You're really doing 6x equals 108. So you divide by 6. Okay, if you can't do it in your head, then write down what you need to write down. So if I do 108 divided by 6, that's going to end up giving me the x-intercept on that is 18. Okay, y-intercept, you would do 4y equals 108. Divide by 4. So I'll take my calculator and do 108 divided by 4. And then that'll give y equals 27. Okay, so we've got our intercepts, and it's important that you start that way before you start putting together your graph. Okay, so what we're going to do is we're going to do what we call a corner graph on this. And so what you want to do is just kind of draw out like this, because x and y both have to be positive. If x and y are positive, you're up here. Okay, you just worry about the corner. And it looks like the X-intercepts are 24 and 18. So what you want to do on this is just kind of ballpark this. I'm going to go 5, 10, 15, 20, 25. That'll probably fit everything on that, and then you can kind of estimate. The Y's, let's do the same thing. Let's just go by 5s. Try to be accurate on this. What I do on a test is I give you a graph paper, so it'll help you to get this more accurately. So we'll take that all the way up to 30 like that. Okay. Now what I'm going to do is I'm going to do these two lines. So the first one I'm going to do in red. I'm going to do just a solid line on this one. So the first one has an X-intercept of 18. So you get that. It has a Y-intercept of 27. Just kind of estimate it. And then draw the line like that. Okay? All right. So we got that. Now, where is the shading going to be? That's less than. So where am I right now? I'm there. I'm below. Okay? So you want to get that established, at least in your mind, that you're below that line. Okay? Whatever it takes to indicate that, do that. Okay? Then I'm going to do the second one. I'll do this one like in blue. Okay? This one has X and Y intercepts are 24. So X-intercept 24, Y-intercept 24. Do that. These graphs are going to intersect like that. And then you're going to be below the blue. Okay, so where am I? If I'm below both lines at the same time, where am I? I'm there, right? I'm in this region here because I'm below both. If you have two less than symbols, then you're going to be below both at the same time. So the feasible region is going to be in here. Okay, so that's what we have. Now we need to just figure out what our corner points are. Okay, so I'm going to just draw a picture. I mean, you don't have to do this when you're doing these problems, but you have 4 corner points. You'll be able to tell me in your head what 3 of them are. The other one you got to use a matrix on. Okay, so you have 0, 0 would be 1 corner point. The other one would be this point here, and then that one was 18, 0. Okay, that comes from that X-intercept of 18. Then you got this corner point here. That corner point there was up 24. So that one's 0, 24. You just look at your graph and get those, all right? Now to get this corner point, you need to do a matrix because it's the intersection of these two equations. So your equation would be 6, 4, 108. The other one would be 1, 1, 24. So you got to put that in your calculator to get that corner point intersection like that. Okay. All right, so I'm going to go to my calculator and just get this. This is the simplest way to get a corner point is just with a matrix. So you have a 2 by 3 matrix, and I'll just put in the numbers 6, 4, 108. Don't go by looks. Go by what your calculator tells you. 108. And then the second one is 1, 124. And then do the reduced row echelon form. So I'll do that. Matrix command, math, reduced row echelon form. And then just get your matrix A to come out or wherever you put it in. And that gives that. Okay, so what's the answer? 618. Okay, so that means this corner point is 618. Okay, so this thing just changed into 106, 06, 118. So those are your corner points. Now when we do the next section, we just do one more thing with these corner points to complete what we call a linear programming problem. The linear programming problems are kind of complex, so it takes a while to kind of build up to what you're doing with that. So the hardest part of that problem, what's the hardest part of the problem? Setting it up. Okay, that to me is usually what students struggle the most with, is setting the inequalities up. Try to put your information in a chart and try to think about what's being related. You have 2 things. You have 2 types of skis and 2 types of productivity. You have the fabricating and the finishing. So you have to put it together into 2 inequalities. Okay. All right, so let's go ahead and take a break here till, say, 1 o'clock. Come back, we'll do 5.3. 5.3 is up here if you need a copy, too. And that's when we're going to put it all together.
Is 5.2 and 5.3 to be on the test?
They are.
Yeah.
Uh-huh. Oh, you okay?
Yeah, I have
Okay. I think that's out of Staples, so you can just put it all together and it should be fine.
Hey, bro.